Greetings and welcome to Lesson 6.3, Addition and Subtraction of Rational Expressions. When we're going to add or subtract rational expressions, it's very similar to adding and subtracting fractions. So if the denominator is the same, then we're just going to add or subtract the numerators and keep the same denominator. If the denominators are different, then we need to find an LCD, rewrite the fractions with the LCD as the denominator, and then we're going to proceed to add or subtract the denominator or the numerators. All right, so for example, with fractions, if I had 1/2 plus 1/2, then it would be 2/2, but then I want to reduce, and 2/2 is a 1. Okay. Very similarly, if I had 3/7 plus 1/7, that would be, well, 3 plus 1/7, which is 4/7. So that's just a reminder of how we're adding fractions. If they have the same denominator, all we do is add the numerators. So let's see this with rational expressions. So let's take something like 5/x plus 3/x. Well, they have the same denominator, so I can write it as 5 plus 3 all over x, which would equal 8/x. I don't know what x is, so there's nothing that I can reduce. If I knew what x is, I could reduce. Let's look at another example. This one a little bit more complex, but we see that it still has the same exact denominator. Okay, so because they have the same exact denominator, I can write it as x plus 3 over x squared minus 9. Now I do need to factor the denominator to see, can I reduce? So x plus 3 is the numerator, and let's see how I can write x squared minus 9. X and x, two numbers that multiply to -9 but add to 0, that's going to be -3 and +3. And it does look like I can reduce. I have an x minus 3 on top, that whole entire thing, and an x minus 3 on the bottom. So I'm left with x plus 3 goes into x plus 3 once, x plus 3 goes into x plus 3 once. That leaves 1 over x minus 3, and that is our solution there. Go ahead and try some problems on your own. First one is 5m plus 4m. See what you come up with. Same denominators, so remember just add the numerators. Second one, x over x plus 4 plus 4 over x plus 4. Again, same denominator, add the numerators, see if you need to reduce. Number 3, 3x plus 12 all over x plus 4 plus 7 over x plus 4. Again, the denominators are the same, so add the numerators. See if you need to factor. If you don't need to factor, go ahead and see if you can reduce. If not, leave it alone, and that's your answer. Now let's consider a couple of fractions that don't have the same denominator. Well, the first step we want to do is find the LCD. So what I'm going to do is break down 10 into its prime factors, break down 14 into its prime factors. They share the 2 in common, so the LCD will take the 2 that they have in common, the 5 that they don't, and the 7 that they don't. So the LCD will be 2 times 5, which is 10, times 7, which is 70. Now I'm going to rewrite each of those fractions so that the denominator is 70. 7 times 10 will get me 70. What I did to the denominator, I must do to the numerator. 7 times 1 is 7. 14 times 5 is 70. Therefore, 3 times 5 is 15. Now that they have the same denominator, I add the numerators. 7 plus 15 is 22 over 70, and the last thing I do is reduce. Down to, well, I could divide each by 2. So 22 divided by 2 is 11, and 70 divided by 2 is 35. So let's take that same concept and apply it with rational expressions. So 3 over x minus 1/2. What is the LCD here? Well, the LCD is going to be 2x. Why? Because x and 2 have nothing in common, so we need the 2 from the denominator with the 2, and we need the x from the denominator with the x. So x times 2 is 2x. Now we're going to rewrite each of the fractions with the denominator 2x. So 2 times 3 is 6, and 2 times x is 2x. And for the second term, I need to multiply both x over x. So 1 times x is x, 2 times x is 2x. So now I have 6 over 2x minus x over 2x. Now that they have the same denominator, subtract the numerators. 6 minus x over 2x. Resist the urge to cancel or simplify those x's. You cannot cross this subtraction, right? So don't reduce if there's any addition or subtraction on top, unless it looks exactly like that on the bottom. All right, let's work through another example. 5 over 2x minus 6 plus x over x minus 3. Now they don't have the same denominators, but the first thing I'm going to do is see if I can factor the denominators. And indeed, I can factor the first one to 5 over, pull out the GCF of 2, x minus 3, plus, and the second, that's an x, cannot be factored, so I'm going to leave it as x minus 3, and I'm just going to put the parentheses around there for emphasis. So what's the LCD? The LCD is everything they have in common, which is x minus 3, and everything that they don't, which is this 2. So the LCD is 2 times x minus 3. Well, the first term already has all of the 2x minus 3, so there's nothing we need to adjust there. 5 over 2x minus 3 plus x minus 3. Well, x minus 3 is missing the 2, so I need to multiply both numerator and denominator by 2 over 2, which is just big fat 1. 5 over 2x minus 3 plus 2x, 2 times x, 2x minus 3. Now they have the same denominator, and I can add the numerators together. Well, 5 plus 2x, I'm going to write it as 2 plus 5 over 2 times x minus 3. And the last thing I want to do is look at the numerator. Can I factor it? I can't factor it. That's it. I'm done. If I could factor it, I might be able to see if they had anything in common. But this numerator I can't factor, therefore I'm going to leave it as the answer like it is. All right, let's check out another example. First thing you want to do is you want to factor the denominators to see what your LCD is going to be. So the first term remains as is, 1 over x plus 4. Second will be 8, and I'm going to factor the x squared minus 16 as x minus 4, x plus 4. And on the first one, I'm just going to give it an emphasis of parentheses. So what would be the LCD here? Well, they both have the x plus 4, so I need that. LCD needs the x plus 4. But the second term has the x minus 4, so we need that as well. Now that we know our LCD, we're going to rewrite each of the denominators with the LCD of x plus 4, x minus 4. In the first term, I'm missing the x minus 4, so I need to multiply both top and bottom by x minus 4, because even though it looks strange, x minus 4 over x minus 4 is still 1. 1, 1, 1. All right, x minus 4 times 1 is x minus 4 all over x minus 4, x plus 4, plus 8, x minus 4, x plus 4. Remember, it doesn't matter what order these two are in, it's multiplication, so order does not matter. Now that they have both the same denominator, I'm going to add the numerator. X minus 4 plus 8 is x plus 4 all over x minus 4, x plus 4. Is there anything here I can reduce? Yes. They both have an x plus 4 in common. So x plus 4 goes into x plus 4 once. X plus 4 goes into x plus 4 once. And therefore, I am left with 1 over x minus 4 as my final solution. All right, let's take it one more step. Okay, first step is to factor the denominator so I can see what my LCD is going to be. I'm not going to rewrite my problem. I'm just going to factor it where it sits. X, two numbers that multiply to 6 but add to 5. That's going to be plus 3 and plus 2. 3 times 2 is 6, but 3 plus 2 is 5. So it will factor the x squared plus 5x plus 6 will factor into x plus 3 and x plus 2. As for x squared minus 9, that will be x plus 3, x minus 3. Sorry about that. Okay, x plus 3, x minus 3. So what will be the LCD here? LCD, well, they both share the x plus 3, so we need that. But then the first term has an x plus 2, so we need that. And the second term has the x minus 3, so we need that. So our LCD is x plus 3, x plus 2, x minus 3. The first term is missing the x plus x minus 3. So let's multiply both top and bottom by x minus 3 to the first term. 2 x plus 3, x minus 2 plus. Well, the second term is missing, well, it has the x plus 3, it has the x minus 3, but it's missing the x plus 2. X plus 2, x plus 2. We're going to multiply that by x plus 3, x minus 3. All right, almost there. Whew. All right, 2 times x minus 3 is going to be 2x minus 6. And I'll go ahead and do one more step here. X minus 3, x plus 3, x minus 2, plus 2, plus x times x is x squared, and x times 2 is 2x all over. I'm going to go ahead and write it in the same order. X minus 3, x plus 3, x plus 2. Now we can combine the numerators. X squared plus air is x squared. 2x plus 2x is 4x. And minus 6 plus air is minus 6. All over x minus 3, x plus 3, x plus 2. But we're not done yet. I want to factor the numerator, see if they have anything in common with the denominator. Two numbers that multiply to negative 6 but add to positive 4. Let's see if we can factor this. Well, 6 and 1 won't make it. Let's see, 2 and 3 won't do it. Is it not factorable? No, I guess that's it. So we get to leave it as is. So unless I'm missing something, 6 can only be 6 and 1, which would be 5, or 2 and 3, which would be 1, because they have to be opposite signs. So nope, not factorable. Therefore, there's my answer. You do always want to check to see if it's factorable, though. Let's try a subtraction problem. X plus 4 over 2x plus 10 minus 5 over x squared minus 25. First thing we want to do, factor the denominators. 2x plus 10 will factor into 2 times x plus 5. And x squared minus 25 will factor into x plus 5, x minus 5. So looking for the LCD here. LCD, well, it needs the 2 from the first one. It needs the x plus 5 that they share in common. And from the second term, it needs the x minus 5. So the LCD is 2 times x plus 5, x minus 5. All right, the first term is missing the x minus 5. X minus 5 over x minus 5. X plus 4 all over 2x plus 5 minus. The second term is missing the 2. So we need to multiply both numerator and denominator by 2. So numerator is 2 times 5. Denominator is 2 times x plus 5, x minus 5. Now I'm going to distribute. We have, for the numerator, x squared plus 4x, but minus 5x is minus x, and negative 5 times 4 is negative 20, minus the 10 over on the second term, all over 2, x plus 5, x minus 5. Let's simplify the numerator. X squared minus x minus 30 all over 2 x plus 5 x minus 5. Let's see if we can factor that numerator. X and x, two numbers that multiply to negative 30 but add to negative 1. How about negative 6 but plus 5 all over 2. X plus 5, x minus 5. Now we see, is there anything in common with the numerator and denominator in yes? X plus 5 goes into x plus 5 once. X plus 5 goes into x plus 5 once. We are left with x minus 6 all over 2 times x minus 5. Here are some similar problems you can try on your own. 3r plus 2 all over 3r plus 6 minus r plus 3 over r plus 2. Also, 4 over x plus 2 plus x over x squared plus 6x plus 8. Another problem is x minus 3 all over x squared plus 2x minus 8 plus x minus 3 all over x squared plus 7x plus 12. Okay, so let's take a look at a word problem, an application problem. Write an expression for the sum of a number and its reciprocal, and then we want to simplify. Well, since we don't know what that number is, let's go ahead and just call it x. So let x be a number. All right. We also need to know what the reciprocal of our number is. Well, the reciprocal of x will be 1 over x is the reciprocal of a number. And we want to know what the sum of our number and our reciprocal of a number. So it would be x plus 1 over x. And we do want to reduce this. Well, let me go ahead and just put a 1 there to see what our LCD is. Our LCD is going to be 1x. So our first term, we need to multiply x over x. Our second term, 1 over 1, but that's just 1. X squared over x plus 1 over x. And we can combine those fractions. X squared plus 1 all over x. Okay, that would be the most simplified form of it. All right, so that's it for this video. Until next time, be seeing you.